In this problem, we are going to do a ranking task. So we are going to rank in order from least to greatest final kinetic energies of the sliding masses the instant before they reach the bottom of the incline. All surfaces are frictionless and all masses start from rest, which means initial speed is just zero. That is important to note. So first I'm going to identify initial and final state for each scenario. So you can see the initial state and final state for each scenario. Initial is at the top of the inclined plane, final position is at the bottom of the inclined plane. And then I'm going to draw a horizontal line and label it as h is equal to 0. It is up to you where you pick, but usually it is best to pick height of the lower of the initial and final state as the h is equal to 0 level. So you will see why I am doing this. There is a reason for that. We have to label the 0 height level. Okay, so that's for the last scenario. Now let's recall the equation for the conservation of energy. We know in the equation we have initial kinetic energy of the system plus initial potential energy plus work non-conservative is equal to final kinetic energy plus final potential energy. So in this course we talk about two conservative forces, spring force and force of gravity. In this question, we don't have any non-conservative forces because it's frictionless and then the work done by normal force is anyway 0. So we have the initial kinetic energy plus potential energy, but initial kinetic energy is 0 because the object starts from rest. And how about the final potential energy? Before we figure that out, let me give you the equation for the kinetic energy and potential energy. Potential energy is mgh, so height is important. Look at the final state. At each of these final states, height h is just equal to 0. That means final potential energy is 0. Okay, mass times g times 0 is 0. So we get initial potential energy of the system is equal to final kinetic energy. So you can see we started from the conservation of energy equation and it boiled down to this simple equation. And now I'm going to calculate the initial potential energy for each of these scenarios, A through F, and that would be equal to final kinetic energy of the system. So for the first one, mass is 10 kilograms and G is 9.8 meters per second squared and height. Okay, so let me write down mass is 10 kilograms, G is 9.8 and height is 1 meter. Right, you can see that is the height, 1 meter. So path doesn't really matter, we just need the height, change in height. 1 meter, so you get 98 joules. And let's do for the second one, I already did it actually. So mgh, height is 2 meters, you can see. So 19.6 joules. And then for B, kinetic energy final is equal to initial potential energy 10 kilograms times 9.8 times the height is 1 meters. So you get again 98 joules, same as A. And then for E, mass 1 kilogram, G is 9.8, height is 0.75 meters. And you get see we get for the final kinetic energy, it's equal to, second guys, 7.35 joules. Okay, and then for C, again you can see mass is 5 kilograms, height is 0.5 meters, and G is 9.8, height is 0.5 meters. And when you calculate the final kinetic energy, you will get 24.5 joules. And for the last one, kinetic energy is equal to mass times 15 kilograms. G is 9.8 meters per second squared. And then height is 0.75 meters. You will get 110.25 joules. Okay, so now let's rank the final kinetic energy starting from the lowest to the highest value. So lowest to the highest. The lowest one is 7.35 joules. That would be E. And then you have D, C, and A is equal to B, 98 joules. Make sure to show that they're equal. And then the last one, the greatest one, is F, 110.25 joules. Okay. All right. So you can see the final kinetic energy was independent from the path taken. So let's see, the all masses have the same kinetic energy. No, that's not applicable for this case. Now I'm going to explain the reasoning for my ranking. So I emphasized this several times. We use the law of conservation of energy here, right? So the law of conservation of energy confirms that for this problem, initial potential energy is equal to final kinetic energy. Therefore, kinetic energy final is just mgh initial. The final kinetic energy of the system is dependent on two variables because it is just mgh. It depends on the mass and the height. And it's very important to understand that final kinetic energy is independent from the path. Okay, so we just need the change in height. The distance traveled along the inclined plane doesn't really matter. Righty. How sure are you about your ranking? 10, very sure.